Happy Wednesday, y'all. Let's see. Where were we? In the process of processing of a transaction stream, keeping track of the transaction ID, database path. It should be UTF-8 string. UTF-8 path. My mistake. We order this right. We could set this up so that this is only ever done when the transaction ID is none. Yeah. Let's put that up here. Current transaction ID. Yeah, database checksum. What do we have on DB? That database says raw storage. Ah, we can get via a special key. That's right. Hmm. There we go. Now, which key do we get? Um, okay, we get something. We await that. Something. Is it correct? Yeah, what do we do with errors in this case? We're processing a stream. Hmm. Double check this. I don't remember which key it is. Use. Actually, README is a better place to get this info. Data archive. And let's see, we want the current checksum of a given database. Technically not database name either. It's database path. One database state. Okay. Shard and database name. Yes. What is the shard? We don't really have a shard setup. Should that be passed in? Is it a property of DB archive? Do we load that off disk? Right? Does this guy just know which shard it's serving? Or does it serve multiple shards? Like, let's say multiple collections of these. I would say it could serve multiple shards. And for that to happen, the other systems would have to pass their shard in, which means that it should come off the request. So we need to adjust transaction chunk. Data proto. Uh, chart. Okay. One, two, three, four. That's okay. That was nice. That saved me a little time. So now we have shard. No such field? I disagree. Maybe we should have some sort of pattern where we raise an error. The error must have some sort of, like the current transaction ID that it's working with. I don't think I've ever returned a tuple for an error. It's interesting though. And we don't want this to be a status. I want it to be a transaction ID along with some sort of error. That dog's barking at something. I'll be back. And we're back. We're back. Okay. Let's check some mismatch. This needs a source. Sure, raw error. Why not? No idea what it's supposed to be. Ooh. There are two different ones. How about we just qualify it? I think it's this one. This one. Yeah, that one's a little different. Where's this used? Let's see. References. Quite a few places. Wow. Okay. I don't like having two of the same kind. This one seems to be better entrenched, though. And we're going to avoid that rabbit hole. Now, what's going on over here? Ah, yeah, we'll get to that. Okay. Back up to where we were. Oh, a key stuck? There it goes. That was weird. My Father's Day gift keyboard and my Kinesis Advantage Pro from forever ago. I don't know if it's starting to go, or if it's the USB hub that somehow misses an action. I doubt it's the USB hub, quite frankly. If that were the case, other things would be happening. All right. So we do this self transaction structure. Now, in this case, transaction ID is passed through. We want to be able to send a response. What is this TX? TX. Stream response. Okay, this is stream sender. Response sender. Our database clone. Great. Why would we? Okay, fine. If we get an error, so what are we expected to send to them? Now this stream here, it's our type, transaction result. It's a result of transaction result. And status. Interesting. So we need to convert this to a tonic status? No, a transaction result is fine. Maybe we do a tonic status if this happens. Who knows? Should probably figure this out. There we go. Transaction ID is changed here. We should use the same type. Here we go. I hit a button. Great. No, I don't want to shut it down yet. Okay. Transaction ID should be the same. Pass that through. Result is interesting in that 0 for success and then non-zero means something else. I don't really care as long as we have a convention that we follow. And this feels contrary to some of the other conventions, except for SQLite. Like SQLite does 0 for success and non-zero values for errors. I don't know what sort of value to give it. I mean, we could have this, have some sort of representation, or why don't we just get rid of this? Can we just do an enum? How do you do an enum? Of enum. Is equal values, right? Kind of basic values. Default value, enum value aliases. Well, let's do this, but define the errors. we call it message or type? Let's see, message. Okay. No, I want enum. No. Success, yes, we'll take that. For these, though, I want specific errors. For example, database checks on mismatch should probably have its own value here, how it maps to that. And then this result code is that result code. It's going to break everything. Okay, so we get our error, right? That's one of our error types. We need to know what our result code is. And so we should do error dot like to result code or something. Something like that. Message is error dot to string transaction ID. That should just be passed through. Oh, transaction result code. Wait a second. Yeah, that's what I want. As I32. Okay. All right. So we've built up our transaction result for when something goes weird inside that. Now we want to send a response. However, what we are sending should be a result that has a. We're not actually sending this. We're sending an okay error as opposed to like a full on error. Just a little weird. I'm gonna say that. Um, but we're expected to be able to keep the channel open and keep trying. Maybe that's let's rethink that. What would we expect the system to do? I guess it depends on the type of error. And you get a database check some mismatch. You're like, uh-oh, something's out of sync. And I need to stop and check my databases. Transaction ID mismatch. This is more of a maybe I start over. Hmm. All in all, none of those should happen. And these are exceptional cases, so maybe, just maybe, instead of having, where'd it go? Instead of it returning anything, we have it return tonic status. Yeah. So thus far, it's something's wrong with the consistency of the system, and we have to recover that. So the writer needs to stop for a moment, make sure it gets into a consistent state, or switch to a different writer, and continue on. But really, we need to inspect and figure out why the error happened. I don't like the stream piece. We should just return that one thing. We don't need to return a result of that. Do we have to return anything, or can we just rely on nothing? Just the regular status response, or the tonic status. Language guide, coding. Where's our service definition? Defining services, returns blah. What's there? What if it returns nothing? Okay. Because you might want it in the future. That's a good response. Okay. However, does it need to be a stream? No, it doesn't. Returns transaction results. Nope, no stream there. Let's do that. Okay. It's no longer streaming the response, at least. This does change the way the function behaves. Because now we have to return not this, but like an actual response. Yes, we don't. We just hold on and then later return a response, maybe. So this just sits there like a. Hmm. Oh, this doesn't feel correct. We get a request. It kind of feels like old school Comet, right? Where you would make a request and just have it sitting there waiting for a response that may or may not come. But in this case, you're just dumping data into the request, and then you might eventually get a response. Let's see what happens. So I believe this implementation is wrong, but for whatever reason, it's not. Ah, there it goes. It's not a member. We just need to return transaction results status. And this should be, I don't care. Let's change it to unit, so it'll give us an actual error. Ah, perfect. Still keep doing helix commands. Why can't I scroll to the right? There we go. Transaction result. Okay, that's content. That's good. However, now we don't return anything here. Like, we can't do this. We have to await the spawn task. If this has an error, we have to bubble that up and out. Why are we spawning a task instead of just awaiting this other thing? Hmm. Let's just take the task away. Okay. If this ends up working, okay, we'll figure that out in a moment. So we process the stream forever. Let's do this where we figure out what our transaction result is. I think this is much more of a match here now. Let's go ahead and. Oh, no, I didn't mean to add that to our chat. Get rid of that. This with match. Great. Error. And okay. So if we have something that's okay here, because this will be final bit, we need our transaction result. We no longer need to do this. Okay. Hmm. But I still think, well, like in the error case, we respond and then we shut down. I think it just doesn't feel right. Onyx status. We have our own codes in here. Other. Hmm. Interesting. What is metadata? It's a map, does not contain. Okay. Hmm. So we could still have our, our enum type. We could still have this. And now this is no longer result code. This is more error codes. Okay, that's fine. So we could add something there, kind of like what these guys are talking about. You may have noticed that it's quite limited and doesn't include the ability to communicate other details. Mm-hmm. It's fine. Yeah, loggers and proxies. Got it. What if it's an error response? I think we can avoid putting sensitive info in it. Um, that's fine. All this here. We put other complex types in metadata. Header map. Values. guess it's just getting serialized. So why not? Interesting. So I wonder if we have access to this. How would we use this? No. I think we would have to import it here somehow and then make it available. Reason, domain, metadata. Let's just use the error info bit. Just grab this. Let's try to use that. Okay, good. And then it's weird. This should be status. It takes two. Yeah, this needs to be a metadata value. Interesting. It's either that or we put reason domain and metadata on the metadata object, which is also reasonable. Hey, Mars. Yeah, it's going all right. It was a little exciting around here earlier. Kids saw a wolf. I didn't get to see it though. Just checking out the chickens. All right. Status. I'm not sure internal's correct. What else do we have? Data loss. Does that have to be a hash map? Hmm. Interesting how that was built. Okay. And what is a metadata value? This is not from stir. This is from something else. Okay, it's from tonic. Let's go look that up. Oops. ASCII metadata value. I think this is really what we're looking at. For whatever reason, this here is metadata map. I don't know why it says it's ASCII in the other. Go to ASCII. Well, maybe that's just because of what we've done. I think I'd prefer binary. An ASCII metadata value, or a binary one. And metadata value is, no, takes a value encoding. Okay. So how do we encode this other value? We have this error info. And it was something else, wasn't it? It was message. Code to vec. Okay. There we go. Bytes. So why is it expecting it to be ASCII? Is it because the key is ASCII? Okay, okay. This metadata value must have been this guy here. So status defines this metadata map, which defaults to one. Where's the implementation? Here we go. And blah, blah. Get bin. Interesting. Where's cursor? There it is. That's not right. Control minus. There we go. This is interesting. So we can basically create one of these, but with this details being bytes here. Opaque error details of the status. Huh. I like that better. If we just pass that in there, that'd work. So instead of this line, move that down. Status. And what was it? From with details. Go to code, message details. With details, code, message. And then our details happen to be error info. Something like that. Status is gone. We return status. Okay. We're not using a transaction ID. That's reasonable. We could include it, but okay, let's change our error message here. We're just returning an error. If there's a transaction ID in the error, so be it. Okay. What's this? This goes away. And we have our success here. So in this case, what is our success? Just unit? Okay, if that ever changes, we would want to know. We send one of those back. Great. No longer have that. Is this even needed? Debian streamer. Just call this off of self. Those go away. Okay. Now, what metadata did we want to include? This isn't very useful at the moment. We wanted to pass the kind of error in the metadata. Right? So in this case, it would include Araga. How are you? Happy Wednesday. Goodness, it's Wednesday already. I finished work, waiting for dinner. Nice. So we need to be able to use. I don't like this so much. I think I want our errors to create this. So essentially, I want like something like so. Yeah, something like that. So let's go up to our error. Here we go. Okay. Now the reason is different depending on the kind here. So let's say match self on that. Yes. Now I don't think that source.toString is correct here. We're going to ignore those and just have our text representation of it. Something like that. we go. Now, what about the metadata? I guess transaction ID would kind of be a natural addition here. Transaction ID is, in this case, not quite that. It's transaction ID from data proto. Okay. All right. We'll have to add that. Let's also add metadata here. Match self, yes. Transaction ID. Does it have to be like that? This can be binary. Oh, it does want it to be a hash map of string. Here. There we go. String to bytes. Now, string does make sense here, but how do I represent transaction ID as a string? So where is it? Here. What does post message give us? Message. Code to vector. Algebra 97. Happy Wednesday and welcome. You want to try to implement a project like this in Rust. How did I gather the requirements about what's needed for a SQLite development? Oh goodness. So I've been working in software for a while. I suspect that the requirements are, I was going to say second nature, but it's not quite that. I had this idea of building these websites using Fly.io with Lightstream. Um, and when I dug into Lightstream, I thought, you know what? I wanted to perform differently than their kind of limitations that they posted. So essentially, I had this goal in mind where I wanted to build something using some technology, and I found that the technology may have not been quite what I wanted. So I thought I'll build a different version that has more constraints to it, but will perform the way that I need. Um, so, start with a goal, something that you want to build, and then, if you don't find the dependencies that you need, build those. And that's where we are right now. This is really a dependency that almost existed. So y.io light fs, and so I've got this thing here. I was basically in the FAQ. What size database is how many, right? What are the trade-offs of using LightFS? 100 transactions per second. And I want to be able to do much more than that. So basically, I started building with LightFS. I've got a whole other like project that's just sitting on a shelf waiting for this to be done. I started building on this, and then I saw this and thought, oh, you know what? Let's go fix it. Let's build something that can do, a couple orders magnitude faster than that. All right. So string hash map. So we need this transaction ID to become a string. I don't really like that. Maybe maybe we can send the pieces separate. And that's doable. Um, or we could maybe implement something special to be able to take that to a string. How would we do that without hitting the um, orphan restriction? This is in a different crate of mine, right? The one that's generating this code. We could, I guess, implement that in data proto lib here. Let's see, transaction ID or a string, something like that. This is close. Sol 1, Sol 2, I change. That's that's fine. We don't need to go the other direction. Now we'll toss a toString on there. Ah, like we should use the other one. See, we're missing. Did I delete one too many? One, two. Good. You thought salt was for kitchen, not for programming. It really depends. Some salt's for roads, some salt's for making ice cream. Might be interesting for distributed CM. What's CM in this case? Does fly phone home? Huh, I don't know. I mean, fly. They're they're just another system. I don't know if they. It's like a some other platform to display your apps on it or to deploy your apps on, like Heroku. Oh, oh, got it. Yeah, so CM is like config management based on sqlite. Interesting. I've looked into Fossil a little bit. It's intriguing, but I don't think it's all that useful to me. Okay. So we have error info. Turn it into a vector. Interesting. Do we have to go through so many layers here? Error info. Now it's a value. Create our status. That's fine. I see. My goal is to make something that can basically think WordPress without like a Postgres back database. I want to be able to build websites, but I don't want to have to manage distributed Postgres. I want files that I can manage the changes between. Exactly what you were using CM for. Oh, that's cool. And welcome, Infinite Starcode. Knighton, happy Wednesday. Thank you for the follow, Algebra 97. Okay, I think we've gotten this function here figured out. We now have a plan for what to do with our errors that we raise. They'll get converted and sent back. Nice. Now let's dive down into the implementation. We are returning result error. Okay. While at okay sum. Yeah, if it's not okay, then what do? We stop? Seems like a weird thing to do here. With context, error stream closed. That's basically what it is, right? We want to toss that out. Get rid of that. Well, that's some. So if the stream closes in an expected way, we're okay. I think this is just going to snowball into multiple errors. No method name with context. Okay, we need to import that. Okay, that doesn't exist. Generate variant. Streams closed snafu. That's actually what I want. With source. What is the source here? I don't know. So if we come back, what errors do we get here? Message. Oh, interesting. It's a tonic status. Okay, we can work with that. There we go. Okay, that works. Good. I don't like this. And one other thing we should do, let's see, a little bit of cleanup here. Is this protobuf based? We are using gRPC. So yes. Now, just to kind of explain what I'm working on, let's pull up the architecture. So the goals to be scalable, favor read-heavy sites. Writing must not be awful. Needs to be fast globally, etc. Right? So when a request comes in, it's intending to mutate. We look at the request, send it to, let's say, a reader or a writer. Right? Readers are on the right, writers are on the left here. Request would come into the application. The application would be using our SQLite VFS. We would detect the change that's being made to the database, notify data plane. Data plane would then take the change, send it to data archive, which would then stream it to the other side of data archive, which would send the changes to the other data plane instances, which would apply those mutations to the SQLite databases so that any reads get the freshest data. I'm so organized. Thank you. Datagrams, but it seems TCP. Um, it doesn't really matter, right? I just want something that sends data from one place to the other. These could be changed out later. In fact, this one here is like a named pipe, um, just for performance sake. We want the mutation side to be super light. So it's trying to read data that's just hit the disk so that it's fresh cache, right? It's in some sort of hardware buffer. And it's not actually, hitting the physical drive. Now we send the database mutations, so on. You've used and seen compressive comms, delta and dictionaries in the header. Yeah, I think if I wanted to improve the channel here and here, basically created a label, get rid of that. Um, I would do an implementation that looked at the actual diffs for the format, right? Because SQLite, like the file format's published, right? Just figure out what changed, send the diff, right? And it would be a diff very specific to SQLite changes. I think that would be, you could use that maybe with some other kind of dictionary compression or whatever. I'm not using a diff at the moment. I'm sending the page, the actual page on disk that changed. So V1, get it working, right? V2, optimize, or V, 1.1, whatever. And we are currently working on the piece where data plane sends data information to data archive, and data archive then sends it to IGI and TIKV. Ah, you're creating a data standard based on SQLite diff to distribute data changes. Interesting. Oh, that's cool. For distributed graph updates. Oh, that's nice. Yeah, it sounds very similar. I mean, I guess I would have some questions. You can see that in my system, I'm favoring having like a single set of systems that handle mutations with a larger set that handle reads. That's part of the goal of mine. But with a distributed graph, are you doing the same thing, or are you expecting to have kind of a multi-writer scenario? I think this is good here. Let's come back to mutate. This. See, we don't need this anymore. Unbound channel doesn't need to be created. Response TX, response RX. Okay, this here is just the result. You're based in space-time boxes. Word line planning? I'm not sure what that means. Space-time boxes. I mean, those are system constraints, right? You either have space or time. But word line planning? Not sure. No, you need the response stream because the result is just this. Usually error though. Good. Right. Move this up. Let's see. Yeah. I like where this is heading. So we have our mutation mismatch times. Oh, because we don't actually return okay. Where's the end? Here it is. There. There we go. Philosophy. Okay. All data. The coloring of a world lines. All matter makes smooth curves in space. And all state can be mapped to colors of the world line, which dramatically changes architecture. Huh. Fascinating. I think I had read that as word lines at one point. So I focused on that, but it's definitely world line planning. Okay, that's cool. What would you use it for? So we deconstruct the transaction chunk. All right, now we can start to specify errors here. Or else, let's see. I think we want an okay or else. So we want to be able to generate the error version. Transaction ID missing. We definitely want, oh, we can't give it a transaction ID, can we? Did we? give it a transaction ID. Look at that, we did. Okay, let's get rid of that. And in this case, this is also hash map no. So that doesn't exist. All planning, exploring possible futures, what if scenarios. Cast every meaningful problem as a what if world line split. What is the size of XID? XID. Um, did I have XID? Transaction ID? No, transaction ID here, it's what, 92 bytes? 96 bytes? It depends on which part of the system we're actually talking about. Because in some parts of the system, we can know which database is mutated by the salts, and some parts of the system we actually determine which is modified based on the relative path name. You know, path name plus salt one and I change value. Okay, transaction admin. I think I want to use the snafu version of that. Let's say with context on an option. I would say transaction ID missing. Now this doesn't, this would be snafu. However, you're probably just barely my senior then. Let's see, where's, so we also don't really have, oh, no, 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 no. My mistake. This is, I did this wrong. We have transaction ID missing, which doesn't have really an error on its own, just that it's missing. And we have transaction ID mismatch, which has two transaction IDs. Goodness. Yeah, I messed that up. Okay. So transaction ID could be distributed and nested. Not entirely. So, pardon the flash of the white on the screen. I can't seem to get this colored differently with like a black with white as the text. Um, but information coming out of the SQLite VFS, because we are using a named pipe in this case, I chose to identify the data that's the database that's changing via a fixed size of data, um, just to make handling the named pipe easier, right? Because we can actually have a lot of data go through the named pipe very, very quickly and rely on the operating system to do the locking for us. So I can actually have multiple apps writing to the same named pipe at the same time, because POSIX guarantees that everything, I guess, on Linux is 4K. Like if basically a 4K amount of data that it will ensure doesn't get interleaved with other processes writing to the same named pipe. On different operating systems, it's different. POSIX says the minimum is 512. Um, so I'm relying on that. Could I reuse IPv6? I don't think it would necessarily help in this case. Because in this case, we're just saying, hey, this thing changed, and the data plane knows how to figure out which file to get the data out of. So data plane receiving this 96 byte message figures out which file it is. I guess it's more than 96 in this case because it also has the position where the transaction changed. So in that case, yeah, it'd be 128 bytes. No, it's still 96 because iChange isn't actually sent in that case. Anyhow, so you have some number of bytes and it figures out which file it is and hopefully it's able to use a hot buffer in order to get the data and send it on. So, and using a VFS, we're able to kind of intercept, what data is actually changing. Um, but we don't do that. We don't send the data that's actually changing across. We let it hit disk and then notify that, hey, this thing changed. So the VFS is designed to be very, very light. And we do a little bit more heavy lifting outside of the kind of hot pipeline of mutating data. What's the difference between the left side and the right side? It's the direction of the data. So in this case, um, yeah, I think technically this one doesn't exist. Whereas in this one, this might. So there's two pieces here. There's no change notify in this case. It's just to know whether or not we're in read-write mode. And in this case, you need to know whether or not you're in read-write mode and notify of changes. So, oops, trying to just move that around a little. A good question. I've not really stared at these all that much. Yeah. I have different versions of this architecture. It started out quite different. Okay, let's add a transaction ID missing. That's fine. Let's correct my previous mismatch. In this case, we have expected actual, and we want, oops, that. Oh yeah. No, and please ask questions if you have questions. Happy to talk about it. Transaction ID missing. That one is fine. See, there's an error up here. What is it? Snafu. Oh, transaction ID doesn't impl display. Fine. Actually, if we do that, if we import display, we don't have to import toString or string on it, do we? So let's go to data proto, live here. Kind of like that, but it's actually this here. We want to write F. These are all self. These can then go away. So if we have this, then we should be able to use a toString on this. Okay. What's going on here? All right, so back to the stream processing end. Again, this is the data coming from data plane on the left side, being sent to data archive, the mutate side of it. Zig has nearly a zero build system. Ah, everyone said try Rust, so you tried Zig. Zig has some neat things about it, though. I've never tried Zig. I've just kind of like I'm Zig curious. Transaction ID, okay. So we toss that if it's missing. If it's, say, incorrect, then we return error. And this would be transaction ID mismatch. Valid data. Oh, interesting. Source. Now this. It's not really zig error though. Or raw error. Is that what I said it was here? I said it was raw error. There's no source. Get rid of that. You'd like to try Rust? Yeah. You're stubborn, so you'll try D next. It's funny. Okay. Comment this and an errors. Let's correct the comment. I sent it. Let's see. Oh, this is cursor. Yeah, I've been trying out the different ones. You can see here we tried to have it do some things, but I find that I end up making more progress the way I would want the progress to be made, especially with this database streaming stuff. I need it to be really light, and I don't know. The different models tend to have weird allocations in different places, and I want to control that better. VS Code bets. Yeah. Yeah, we have our little ball. We can throw the ball. Oh, the cat. Oh, it bounced and the cat missed it. Here, let's try again. Throw another ball. No. They try to run for it. Sometimes one of them will get it. Oh, is the crab going to get it? As it very slowly walks across the ball. I have no idea what the crab's doing. Or if maybe it has to get it on like the left side. Who knows? Okay, good. Extract the transaction ID from the first chunk. Yes. Okay. What's that? Now here, if the DB name changes, then we need to load the DB checksum of the new DB path. Yes. So if they are not the same, then we load the DB state. If the transaction is something, then we need to have some sort of error here. Database name should not change mid-transaction. Sure. We should probably have, let's see, a transaction ID. What else? That's going to be current transaction ID. So let's change this into a if let sum. And then the database name. In this case, that should be a string. Technically, they're strings in this case, but I know I changed that earlier in the stream, but actually I can. Oh, that's great. Generate variant. All right. Now, how do we actually get that? Oh, yes, self now. Thank you. And in this case, we need a new error for what error do we get back here? Is this a raw error? This is a DB error. Okay, it's fine. Let's not say storage snafu. How about database state snafu? We should have the path and yeah. Say could not load database state. What is this? This is database name changed mid transaction. Oh goodness. Fine. And those are dot dot. Database state missing. Hmm, that's not right. Should be load. I don't want error in that. How about just database state? Mm, it's so vague. It actually means something else because we have a key that's called database state key here. Let's see. Ah, there we go. Database state key get. Why not? Okay. We need new and current DB path. Why is that? Oh, it's a reference to a string because of the match. Good afternoon, museum. You bought a chess set recently, but it was missing some pieces. I guess I'll have to go to the pawn shop. Nice. All right. Oh, where did I put Discord today? Let's toss that in Discord. Those are transaction IDs, yes. You cannot put your data in comments. Your free memory. Wouldn't that be nice? Hash map from DB path. Okay. I don't think we need source in this case. That was already sent. Okay. Now back down to the implementation. Okay. Good. Now for the pages. Verify that the starting checksum matches the current checksum. That's if we have a current checksum. Should we always have a current checksum? I think we should. Over here, we're getting the current checksum. This needs to be set. What's going on here, though? If the name changes, then we need to load the DB checksum with a new path, yes. In the case that the paths don't match, we return an error. Something's wrong with this. What is it? it I'm going to pour some hot water real quick. I think it's this. Okay. So in this case, the error is that we're changing database name as we're doing this, and then we are making this a little bit more complex with this check here. Why even have this check? Because if it's the same, then we just continue to use the existing database checksum. Right, database DB checksum option to a DB state because it might not have loaded. And this returns a result to an option. Okay. I think that people who like Impressionism art are too materialistic. They are all about Monet. sec, I got a message. Where's my message? Here. Should be fine. All right. These are very similar, just subtly different. One is because there's an actual error. The other is because we just don't have it. Now, there wasn't some database error, just let's rename this. I was asked to name the eighth letter of the alphabet. I was wrong. That's fine. Don't match arms again. Like this also needs like a transaction ID or something. back to where we were. So if we are looping through these transaction chunks, and if the path changes and the path is not the same as previously, return an error if there is a transaction ID. The path should only change after a commit record and before at the very beginning of a transaction. Okay. Because we'll set the transaction ID next. We then attempt to load the DB checksum of that database so that we can compute and validate all of the changes as they come through. So we look up the database checksum based on the path. Great. Look at the key, DB checksum value. Let's rename this. Database state key. Sure. If DB checksum, then we check to see if we have a DB checksum, return an error if it's missing from the database. We have one. And let's what was our type? No, this was database state. State. We want the checksum. What else comes with a database state? Oh, whether it's deleted. The current, the last known good transaction ID. Yeah, that'll get updated at the very end of these transactions going through. Basically, once we know that the whole transaction is good, then we update the database state to point to the new transaction. Okay. I think we can ignore the rest. Current DB checksum. This is option to U32. Interesting. And what do we have here? It's a U32. Oh, this should just be checksum. Okay. So we set the database checksum. Otherwise, we return an error. And that's if they don't match. If they do match, then we just continue to use the current database checksum, which is fine. So it saves us hitting TIKV once. Okay. That's good. This feels like it's a waste to have the match here. But somehow also convenient. How else would we write this? We would say if, can we do, huh. So DB path is a string, whereas current DB path is an option. No, they're both options, aren't they? It's a string, that's an option. Okay, I was right the first time. So we could, in fact, just check to see if they differ. Some DB path is not equal to current DB path, right? Do a bunch of stuff in here. However, it is nice to have current DB path unwrapped for us, which is what the match does. We need it here, so we need to unwrap it in that case. I don't really want to do like a if let sum for current and then check to see if they differ just inside of it. I do like this here. It says like, okay, well, if it's something and it's this thing, or it's not this thing, well, I guess this could be none, couldn't it? We are validating that it is something. So none is different. There's a lot going on in this pattern here. I feel like it should be simplified. This here feels like a bad smell. Okay. Just play around for a moment. If let sum smell, sure, we do that. And then if current is not equal to db path, then we do this and put the rest in here. That reads better than this. Yeah, it does. Also don't like that this is hidden. This here feels hidden. To make it more obvious, perhaps we assign something and do the assignment outside. I don't like it. So let's do something else. Let's say self dot validate db path, and we pass that. Actually, we have to pass the current db path in as well. Validate. Oh, no, no, stop. Cancel. Check. Stop. Okay. do this. I want to take this out of it. At least a part of this. This piece here. What is this? Current transaction. Oh, wait, that's right. Um, There one of these. Oh, interesting. We actually have an opportunity to validate more state change. So if current DB path is none, then it's, and this is some, we should also have an error. Interesting. Fascinating. Okay. Sure, stamp out some of these. None is fine. And if nothing exists, then we're at the very beginning of the transaction. If current transaction ID is none, and we have current DB path, I think that's okay. This is okay. I guess technically it needs to match. Or does it? No, we're okay to change because we're at the beginning of the transaction. Because that's none. Let's move these back down. These two, same thing. So for inner transaction and current DB path is something. Actually, what if it, so if it's nothing, this means that yeah, it's like a inconsistent state. This is more of a logic error on our part. So this is more of a panic. Um, Something like that. Outing. Thank you for the follow. Okay. Because the sum isn't covered. So if they do match, we don't care. In this case, we do. Let's separate them so that we can have a comment. So this would be the case where current DB path and the DB path are the same. So we can do that there. And then we're free to change some of this. Don't need that. What was it? Current. Oh, yeah, yeah. Okay. But it's not an error if we don't find it, because it could be a new database that we're being sent. Uh, that's not an error. Goodness. Okay. Match. So in this case, we return okay. No. Okay. Sum. Checksum. Good. Now, if there was nothing, we will return okay. None. Then why aren't we just mapping that? Why is this just not? Same thing. Or we toss this up here. And then it's just up or. So we either set it to the first page's initial DB value, or we set it to something else. Or maybe we just leave it as none for now. Because that's mutable. We could just assign it. And if they're both none, then we would just set it to none. If we were later setting it to something because the initial page value is set. 4 is a good value. Chosen fairly by a 60 roll. Yes. I think it's if it's something, then want to replace the other one. If it's nothing, then it's actually a concern that happens in here. It's like it was listening to me. Okay. So we validate, we get the checksum. What's happening here? Here we are validating that the transaction ID is consistent. So we need to finish out the transaction ID. Finishing it out would be setting it to none. Oh, D6. You know, museum. I thought that was like a local thing. Like maybe in different parts of the United States, they see their D&D like die specification differently. Kind of like, pop, soda, Coke, you know. So this is behaving much more like a if let sum. If it's the first one, well, this is okay. Just one hand faster than the other. Oh, goodness. Okay. I think this section, this chunk here is now satisfactory. Get down into this piece. I've been explaining this to my kids as like trying to drill a tunnel from both ends. Like I started over here on the right side. I did a lot of VFS stuff. There's still some little side tunnels that need to be patched up on that. All right, but then did this side of data archive, came around here, started building this side of the VFS, got data plane mostly working, and we're just trying to get this part of the tunnel passed through. So one of them said to me, "That sounds hard." Let's see. Okay. So what are we going to do here? We are within this page setup, transaction result. Yeah, and then we have the commit record bit. That should be inside of the for loop. Is that? No, that's outside the for loop. That's weird. Thank you, AI. Um, I just want to gut this. Gut this. Yeah, something like that. Yeah. So much better. So we have our database page. I'm gonna let the dog out just a minute. Okay, dog's out. Said hi to one of the kids. We actually have to do this in kind of a backwards direction because it's okay to save data into this as long as you get it consistent before you update. It's these two pieces. So the rest of this really relies on checksum, transaction ID, and, and kind of the page number, transaction ID. So these can go in and not affect current databases, right? Once everything has been stored and you get that um, the end of the transaction, you can adjust the page size if needed and the state, which has checksum, transaction ID is deleted and page count, right? And arguably, we're not sending is deleted. Probably should, but we're not doing that yet. That'll come in kind of a future iteration. Yeah, page size, goodness, that really shouldn't be changing. I guess unless somebody wants larger pages to store more data. Okay. I've been going at this for about 3 hours. I think I'm going to take a break. Probably do more of this tonight off cam. Um, but I want to get this stuff in and the, yeah, I want to get this data written and the streaming onto the next piece. I think would be good. Yeah. Archive streamer. Okay. Let's see. Who is streaming Rust today? Nobody. Oh, Tom is. Let's raid Tom. Thank you all for hanging out. Till next time, y'all. Bye bye.